Hey guys, it's Young Math Tutor, and today we'll be going over limits with trig functions, specifically when the limit is when x approaches 0. So first things first, we're going to need to memorize a few theorems. Very simple, but very crucial. The first one is the limit as x approaches 0 of sine x over x is equal to 1. So they're just saying that whenever you see sine x over x, and the problem is saying as the limit as x approaches 0, then it'll automatically equal 1. And then the second theorem is pretty much the same thing, except we would say the limit of x over sine x as x approaches 0 equals 1. The same thing, except we're just flipping it over. And our third theorem is also very similar, but this time we're going to be using cosine, so it'll be 1 minus cosine x over x. And we're saying that the limit of 1 minus cosine x over x as x approaches 0 will equal 0. So we're going to use all these theorems as our base, right, and use them to solve all the upcoming problems. So let's look at our first example. So we have the limit of sine 3x over x as x approaches 0. So in these types of problems, what you first want to do is you want to make sure that the coefficients are the same, right? Because in the theorem, it has to be, sine x over x. So in this one, we want it to be sine 3x over 3x for it to be able to equal to 1, right? And so for us to do that, we have to multiply both sides by 3. So 3 over 3 times sine 3x over x, right? And to visualize it, this 3 is going inside the parentheses to be multiplied with the x over here, and we'll be leaving this 3 outside. So let me just rewrite that. And so we'll have 3 times sine 3x over 3x. And now we know from the theorem before that this right here is equal to 1. And we just bring the 3 down, so we get 3 times 1, which is 3. So that would be the answer for our first example. So let's move on to the next example. It's also very similar, but this time we want to get the numerator, the top, to become 2x, sine 2x. So to do that, you just gotta do the same thing, except we're multiplying by 2 over 2, right? And this time, the top 2 is going to multiply in, which will leave us with half. And now we have sine 2x over 2x. And of course, you got to write the limit as x approaches 0. And we know sine 2x over 2x gives us 1, so we get half times 1, which is half. Very simple, very easy. You just gotta multiply, essentially. Let's look at another example. This time we're going to be using cosine. And it's the same thing, you just have to multiply. We gotta make sure that the bottom is also 7 as the coefficient. So let's just rewrite that. Limit as x approaches 0 of 1 minus cosine 7x over x and times 7 over 7. And so in this one, the 7 is going to be going over here on the bottom. So if we just rewrite that, we got 1 minus cosine 7x over 7x all multiplied by 7, which is left over on the top. And so we know this right here from the theorem gives us 0 times 7, which gives us 0 as our answer. This is also fairly simple, right? The same idea. So now let's look at an example where they give us a trig function, but it's not in terms of sine or cosine, and we can't really figure out how to get it into that form for the theorem to apply. Well, in this situation, we can easily tell that cosecant x is also 1 over sine x, according to the trig identities. So let's just rewrite that first. So it'd be x times 1 over sine x. And if we just simplify that, right, we get x over sine x. And that is like directly from our theorems, and it states that that will equal 1. So it's very simple. You just got to make sure you convert everything into terms of sine x or cosine x, and so you can make the theorem apply. Now let's look at another example in which you can't figure out how to even make the bottom or the top just x, right? This one has both sine 3x and there's a 2x on the bottom. So in this situation, you're actually allowed to separate the fraction into two different limits. So we'll have limit of x as x approaches 0 of sine 3x over 1 times the limit as x approaches 0 of 1 over sine 2x. So now we can just solve this as two separate problems, and then we'll multiply them together. And so for the first one, we're going to have to multiply by 3x to make the theorem apply. So we get limit as x approaches 0, and we're multiplying by 3x on both sides. Alright, and so this 3x will go on the bottom, and we're multiplying by the limit as x approaches 0, and we'll have to multiply by 2x on this side. And so now if we simplify, we're going to see that we get 3x, and once you get used to these problems, you don't have to show this step. We can see that it'll be sine 3x over 3x when we multiply it in, which will give us 1. So we'll have 3x times 1 times, and this one, 2x on the top is going in, so we'll be left with 1 over 2x times 1, which gives us 3x over 2x, and we can just cancel out the x's, which gives us 3 over 2 as our answer. So this is also fairly simple. This may seem complicated, but if you just separate it, take it step by step, it's essentially just solving two problems and then multiplying the answers to get what you want. And that is pretty much all you need to know. Just a quick recap. First off, you want to make sure you remember these theorems right here. They're very important. Pretty much the only way you can solve these problems if you remember these theorems. Then you just want to make sure that you multiply by the number that's missing. See how it's sine 3x? We're missing a 3x on the bottom. So multiply by 3 over 3. And that's pretty much all you need to know. And for the tricky questions like I showed you over here, you just want to make sure that you split up the problem so that you have like two separate problems and just solve it like that. So if you have any questions, just drop a comment down below and I will see you guys later.